This is a demonstrator of the PoC-3 network of networks tested, presenting a 6G cloud architecture based on a cloud-native approach and a multi-cluster Kubernetes environment. Overall, it demonstrates a practical implementation of a flexible and scalable next-generation network in an operator environment. The PoC environment is built around the CCF and MOF orchestration framework, which enables automated service deployment, policy-based management, and resource coordination across multiple clusters. Kubernetes clusters are integrated through Karmata for multi-cluster orchestration and connected, using Cilium Mesh for cross-cluster networking. The architecture also incorporates Kafka as the message broker, Helm for application packaging, and Terraform and Ansible for infrastructure automation. Our test architecture includes for Kubernetes clusters, deployed across the PL5G lab, and the Orange infrastructure. 3 clusters are located in the PL5G lab environment and are interconnected through Cilium Mesh, providing unified cross-cluster networking and service communication. The 4th cluster, deployed in the Orange data center, hosts the 6G Cloud baseline environment and is integrated with the PL5G lab domain. In parallel, a legacy Kubernetes cluster running the 5G core is allocated in Orange infrastructure. In Orange data center, the SDN network service with ONOS controller was installed in 6G-Cloud OPL 1 cluster. Next, in the Orange data center, load balancer and vSwitch was installed on connected to existing SDN. In the legacy cluster, an instance of the 5G core, Open 5GS, is installed. In Kubernetes CLI, we can see the status of legacy network pods and example pods with Ceph, UPF, IMF, and other 5G network functions. In the next step, we start the CCF functions for deployment of the network service, OVS switches. The application installs the network service on the cluster indicated by MOF. In our case, the deployment process is triggered by sending an appropriate command to the CCF message bus, Apache Kafka. As we can see in the terminal in the bottom right corner, the network service pods have been created in the 6G Cloud cluster. Next, we can deploy the pod that we will use for testing. In the ONOS network topology window, we can see the appearance of a new host and its connection to the existing SDN network. It is also possible to perform a ping connection to the test pod deployed in the 6G cluster. In the next step, we connect the legacy network, the 5G core, to the 6G cloud infrastructure. Similarly to the previous case, OpenSwitch is installed on the worker nodes of the legacy cluster, and the pod with the UPF is connected to it. Finally, we can test the connection between the load balancer and the legacy network. Traffic can be dynamically forwarded between different clusters and network domains, confirming seamless interoperability between traditional 5G infrastructure and cloud-native 6G services. This demonstrator shows how legacy 5G systems and cloud-native 6G cloud infrastructure can operate as one integrated platform.